Right. Overall, the synthesis for this kind of stuff isn't too tricky. We have to be careful when making really complex molecules. Once you start adding multiple functional groups and you start doing other reactions, there's ways that those functional groups can react with your reagents in a way that you didn't intend. So overall, we're going to keep it pretty simple. Let's go ahead and take a look at taking acetone over to this compound right here. The first thing that we notice is that we have a 1, 2, 3, 4, 5. They're in positions 1 and 5, which indicates that's probably coming from a Michael addition. And if you think about where you're going to break your bond, you originally had acetone, which is right there. And so what you're going to add to that one is right there, right? So you had acetone, and then it somehow got added to that position. If you think about it, that could have been an alpha beta unsaturated ketone. And then if we think about this one cannot act as a Michael donor because it's not doubly resonance stabilized. And so what we have to do here is the enamine synthesis, right? So we'll have our amine with 2 R groups to form our enamine. And then that can go ahead and attack our alpha beta unsaturated carbonyl and do an aqueous workup, and you'll end up with the correct product. Here we notice that we have a beta hydroxy ketone. And so when we're talking about forming a beta hydroxy compound, that's probably coming from an aldol reaction, right? So again, there's our acetone. Go ahead, break that bond right there. So we had acetone as one of our reagents. And then this would kind of be that other one. And where did that come from? Well, that came just from another acetone, right? Being attacked at that carbonyl position. And so to get from the left to the right, it's just an aldol reaction. So we just add some sodium hydroxide, and then we do an aqueous workup, right? The acetone is reacting with itself to give us our final product here. And then finally, this is the kind of trick that we last learned, right? How are we going to get the cyanide down here in that position? Well, that must have come from this alpha beta unsaturated carbonyl, where our cyanide is a relatively weak nucleophile, and so it'll attack that beta position instead of attacking the carbonyl position. And then where did this ethyl come from? Well, that's that trick that we learned right now. We can add 2 things at once. But before that, we've got to form our alpha beta unsaturated carbonyl. How do we do that? Well, we learned that through the acidic bromination and then addition of a base. Right, so insert that bromine there, and then essentially do an E2 elimination to end up with our alpha beta unsaturated carbonyl. And then once you've got that, we can just add our nucleophiles. First, we want to add the cyanide. So that'll attach at this beta position, and then we'll have an enolate intermediate, so we can just add our alkyl halide right there. So overall, these syntheses probably won't be as difficult as some of the previous ones, just because once we start inserting, alcohols and carbonyls and whatnot, we limit the kind of reactions that we can do because of a lot of our reagents might interact with those in unintended ways.